Hello students, this class we are going to discuss about next topic of the electrostatics after electric field concept, that is electric dipole concept. It is most important topic and many times in the competitive exams, mainly in mains and advanced level questions are asked on this electric dipole concept. So first, what is electric dipole and derivation for expression for electric dipole, and board for and concept based we are going to discuss first, then after we'll go for applications and problems on that. So today class will complete the dipole basic concepts here. So what is electric dipole? Di means two. If you observe the term, di means two. So di means two means two charge based concept. Consider two, okay, unit charges. Consider two unit charges, one is q, second one also q. In this case, the electric dipole is a concept of related to two charges which are similar magnitude, that is q and q, but both are opposite. One is plus charge, if you say, second one is minus charge. When these two charges are separated by certain distance, this is the line joining between these two charges. I can say this is separated by certain distance. Now this distance is the main factor here, that is small distance. How much distance? Small distance. How much small distance you have to take? That distance which you are taking, always we are considering from the center of these two charges. Means this is plus q minus q, two unit charges I taken which are equal in magnitude, opposite in nature. Along the line joining between them, from the center, both are separated by distance of L and L. Now that means these two charges are separated by distance of 2L. This concept is called as electric dipole. What is electric dipole? Two equal magnitude, opposite nature charges separated by a small distance of 2L is called as electric dipole. This 2L distance is not a large distance, it is a very small distance. Under the concept of that small distance, this combination of two charges will exhibiting some effects in the nature. So that's why we are discussing this concept. So statement we can write here. So now what is the statement of this one? Statement we can define like this: two equal magnitude and opposite nature charges separated by small distance is called as electric dipole. So plus q minus q, both are same magnitude, opposite nature, separated by small distance, we will call electric dipole. This electric dipole we are indicating with the letter P, and this electric dipole is a vector quantity we are indicating with arrow. So electric dipole is equal to, in mathematically we can write in terms of, okay, P, that P we can write in terms of charge into, it is the product of charge into length of that dipole. So in this case, electric dipole is a vector quantity, charge is a scalar quantity, but length is a particular vector quantity because in a particular direction we are measuring the dipole, okay, length. So what direction the dipole, okay, length we are measuring, what direction we are, okay, the dipole moment will be takes place. The dipole, okay, electric dipole is nothing but it is a product of charge into length of that one. The electric dipole is one of the vector quantity. That means the electric dipole nature we are expressing using one of the concept called electric dipole moment concept. That moment is in a particular direction. What is the direction of that electric dipole moment is, if whenever you taken the positive charge and negative charge, this electric dipole moment always, okay, in between the two charges from negative to positive direction it will be. This is the direction of the electric dipole moment. Suppose if you take a negative charge, this is positive charge. In this case, the electric dipole moment will be in this direction. This is most important point you must remember. So electric dipole is always in between the two charges from negative charge to positive charge. It is a vector quantity. It is a product of magnitude of the charge into length of that. That length is a vector quantity in a particular fixed direction, always from negative to positive only. Now what are the units of this one? The units of this one, the dipole moment we are measuring in terms of charge means coulomb, length means in terms of meter. Coulomb meter is the unit of this dipole moment. Now next, if you come across here dipole, I taken here one is positive charge, second one is negative charge, separated by small distance we called 2L, right? So this is the line, dashes line taken, this is called as axis of the dipole. the line which you taken along the line joining between the two charges, that is positive and negative, is called as axis. This is called axis of the dipole. Now the line which you taken, okay, along the axis, that means axis means in between the two charges. If you extend that line outside, this line also called as axial line of the dipole. This is called axial line of the dipole. Now if you suppose if you taken the line from the center of the dipole to like this is the way if you taken the line, this line is called as, okay, equatorial line of the dipole. Equatorial line of the dipole. So whenever you take in the dipole, the line joining between the two, okay, positive and negative charges is called as axis. Along the axis, if you take in a line called as axial line. If you take in the perpendicular, then that is called as equatorial line. Equatorial line always makes an angle 90 degrees with the dipole, and axial line always makes an angle theta is equal to 0 degrees. So now we are going to discuss the next topic, that due to these charges, okay, these are the two charges are there. You know that according to charge, each charge produces of its own electric field around the charge and around the space. So these two combination of charges produces the electric field at different points. That is, the different points means I can take that point on the axial line, that electric field along the axial line we are going to calculate, and that also produces the electric field along equatorial line. So we are going to calculate the electric field along equatorial line. Not only that one, it can produce anywhere. So one of the point I can say here, electric field at any point, that is at any angle, also we can able to calculate. So dipole produces the electric field around it, and that electric field strength due to dipole we are calculating along axial line, along equatorial line at any position. Now the derivations we are going to discuss. Now we will discuss about electric field due to dipole. So we are going to calculate the electric field due to dipole, first along axial line, next along the equatorial line, then after at any angle. First along axial line. First, what is the axial line? The line which you taken along the axis of the dipole called as axial line. So here I taken two charges minus q plus q, and both are separated by small distance 2l, and these charges are separated by distance of L from the center, both the sides L and L. Now I am taking the, okay, axis of this dipole. So this is the axis of the dipole, I can say. This is the axis of the dipole, so which passes through the, okay, axis of the dipole. This is called axial line we are calling, yes or no? The line which you taken along the axis of the dipole is called as axial line. Now on this axial line, at this point or anywhere at a point, I want to calculate the electric field intensity. What is the electric field intensity at this point? P. This electric field is called as axial field. Why we are calling axial field? Because it is along the axis of the dipole. To find this one, what we are doing is, this is the charge which is having. Now from the charge, this point I choose, then I can choose that point anywhere. I can choose the point anywhere. That point chosen at distance of x. So according to the diagram, if you see the diagram, so basing on the diagram, we can write some conclusions here. From this first positive charge, now what is the distance of this one? Always remember, okay, here we have to understand this, the x is whatever you taken, don't take the x, because always you have to take the distance of the anything, either charge or point or anywhere, but always you have to take with respect to center of the dipole only. So with respect to center, I can say this is the distance of the, okay, point we have to take. This is the distance of that point. So what is the distance of this one? You take this distance is equal to, okay, from the point is equal to, you take it as x from the center. If you taken from the center as x, in this case, the first charge which is there, this is the positive charge. This charge is a distance from here is equal to how much? That is nothing but L minus, sorry, how much the distance? X minus L is the distance of that. We have many methods are there. We'll discuss that. X minus L is the distance of that. Or otherwise, if you want to take that in, okay, from the one end also we can take it. That is nothing but x minus L. So if you taken this, okay, second charge, what is the distance of the Okay, charge from the second one. From the negative charge, the distance is, this is the distance of that one. What is the distance? How much distance it is? The distance of this one is equal to, from here to here is L. The total distance is L plus X or X plus L. So two charges positive and negative separated by distance of X minus L and X plus L. I can write. So if you want to write, you can write in order X plus L or X minus L. Now I am finding the electrical intensity at that point. So keep it in mind that at what point you are finding the electrical intensity, you have to imagine a test charge. Now this plus Q repels this one. What direction? Away from the charge. So this is the direction of the repulsion of this one. This electrical intensity due to positive charge you take as E plus. Next, the negative charge will also apply the force on the test charge, that is attracts this test charge in this direction. This electric field you take it as E minus. Now which is the stronger one? E plus is stronger because it is near. E plus minus is less because it is far distance. So net electric field intensity at that point is equal to electric field intensity at that point is equal to, I can write as electric field intensity due to E plus minus E minus here. Now take the E plus formula. What is the electric field intensity due to positive charge? According to formula, electric field intensity due to any charge at any point is equal to 1 by 4 pi naught charge. What is the charge of that one? Q by square of the distance. What is the distance of that one? X minus L. So I can write X minus L minus second. What is the electric field due to negative charge? That is 1 by 4 pi epsilon naught. The charge is Q by square of the distance. What is the distance from negative charge to the point? That is X plus L. That is nothing but X plus L. Now solve this derivation. We are going to get E net is equal to, that is nothing but electric field at point P is equal to, what I can take it common here, that is Q by 4 pi epsilon naught, you take it common, remaining is 1 by, okay, X minus L whole square minus 1 by X plus L whole square. Now take LCM of this one. If you take an LCM of this one, Q by 4 pi epsilon naught, if you take an LCM of this, what you are going to get? X plus L whole square minus X minus L whole square by, that is X minus L whole square into X plus L whole square. If you solve this one, electric field at that point P is equal to Q by 4 pi epsilon naught into, so this is in the form of A plus B whole square, this is the form of A minus B whole square expanded. So I can write X square plus L square plus 2x into L minus X square minus L square plus minus of minus plus 2 into X into L total divided by, this is in the form of A minus B into A plus B whole square. So A plus B into A minus B is A square minus B square. So I can write as X square minus L square whole square. I can write. Now in this case I can cancel the plus X square minus plus L square minus L square, I can cancel. Remaining I can write as electric field intensity at that point is equal to Q by 4 pi epsilon naught into, that is nothing but 4xl by 4xl by this, I can write as X square minus L square whole square. We can write. Now this expression we have to write in the form of, okay, this expression we have to write in the form of dipole moment. What is the dipole moment formula? For any dipole moment we are indicating with the P. P is equal to, that is nothing but Q into length of that. Yes or no? So in this case Q into 2L. So here we have a Q and length we have 4L. So this 4L I can write in terms of 2 into 2L I can write. After writing this one I can write as in terms of, if this 4, if you written as 2 into 2, that is 2L into Q, I can write as P. Remaining 2 I can write like this, that is nothing but, okay, that is 2P. I can write 2 times of this is 2 is left and remaining is P, 2Px by, okay, this is denominator give it to 4 pi epsilon naught into X square minus L square whole square. This is nothing but called as electric field intensity due to dipole along what direction? Along axial direction, that is called axial field. Now in this case, actually dipole length is very small. Dipole length is very small. That means if the length of the dipole is much smaller than compared to distance, that means what is the point of, okay, you chosen to calculate the electric field if that length, if the distance, this distance x is very bigger than compared to this L. L is very small. In that case, L value almost you can take it as 0 in the expression. So electric field at that point is equal to, due to dipole is equal to what I can write, that is 2 pi x by, that is 4 pi epsilon naught into L value. If you put 0, you are going to get x power 4. So x, if you cancel 3, you are going to get. So this equation 2p by 4 pi epsilon naught x cube will be. So electric field intensity at that point is equal to, we can write as 1 by 4 pi epsilon naught, that is dipole moment p by x cube here. So if you observe this equation, in the case of electric field intensity at a point due to charge, we are getting E is inversely to square of the distance. But in the case of dipole, the electric field at a point is inversely to cube of the distance. Cube of the distance. If the length of the dipole is very small. If you consider the length of the dipole also, then this is the formula it is. What is 1 by 4 pi epsilon naught constant? What is P? Dipole moment. The dipole moment formula always you have to know as Q into 2L by x is what? Distance of the point. So cube of the distance of the point here. Now here our point of discussion, one more point of discussion we will do. What is the direction of this electric field? What is the direction of this electric field? Now we have E plus. Now look at the condition at this point P. We have two electric fields are there. One is this, is nothing but E plus, this direction. Another one is E minus, this direction. Right? If you observe this, E plus is near, E minus is far. That means E plus value is more, E minus value is less. That's why the resultant of these two always you'll get, okay, the resultant of these two always you'll get in this direction. What direction? This is the direction you'll get always. This is the direction of the axial field, electric field. This is the direction of the electric field. So if you observe the dipole moment, what is the direction of the dipole moment? Left to right. So the dipole moment is left to right. This is the direction of the dipole moment. The electric field also left to right. That means I can say here, okay, electric field along axial line is exactly parallel to dipole moment. This is important point. That means what is the angle between the electric field and dipole moment? That is theta is equal to 0 degrees in the case of axial field. So electric field due to dipole along axial line is parallel to dipole moment. It is always, okay, in the direction of the dipole moment only. That is important point you must remember. Now we will discuss electric field due to dipole along equatorial line. What is equatorial line? I taken dipole here. One is positive, negative charge. Second one is positive charge separated by distance of 2L from the center. Now the line which you taken perpendicular, which makes an angle 90 degrees, is called as equatorial line. Now along this line, due to these two charges, there may be a electric field intensity. That electric field intensity we need to calculate. So I am taking here the point. Anywhere I can choose this point on the equatorial line from the center of the dipole, because the distance of the point, charges, everything, always you have to calculate from the center of the dipole only. So from the center of the dipole O, the distance of that point I taken as x. So that means the point is at a distance of x, point P is a distance of x here. Now we are calculating the electric field intensity at that point. That electric field intensity we are calling as, okay, that is equatorial electric field. So in this case, to identify the direction, first imagine the test charge at that point P to identify the direction of the electric field due to both dipole charges. One is minus Q. So at this point P, what is the direction of the, okay, electric field? So this is the one of the test charge you have to imagine, that is always positive. So this dipole negative attracts the positive. What direction? This is the way it is going to attract. This is the direction of the attraction. Clear? So this is the one direction of the force I can say. Next, similarly, this is the direction of the electric field I can say. The positive, the dipole positive repel this dipole positive in this direction as you're looking here. This is the way it is going to repel. So this is the way it is going to. So we can find here two electric fields are identified. One is due to negative charge of the dipole, E minus. Second one is positive charge of the dipole, that is. Now if you observe that both are separated by certain angular separation. So here if you observe this, we got one of these structural, okay, right angle triangles from the center you got. Now they are making some angle theta here. Yes or no? So this angle theta. So in this case, these two are separated by a certain angle. Now what I am doing is, now if you observe here, two electric fields E1, E minus, E plus, both are separated by a certain angle. Then the resultant of these two will always act in the direction of like this. This is the way the resultant will be like this. Now to explain this one, how much angle this, okay, making the dipole is making, the dipole line and line joining is making same angle. It will make here theta, here also it makes an angle theta. So what you do is resolve this E plus and E minus into components. If you resolve E plus into components, one component you are going to get, that is E plus cos theta you are going to get. Second component you are going to get along vertical direction, that is E plus sin theta you are going to get. Similarly, E minus if you chosen, this is also making an angle theta with this line, resultant line. So that I can write as E minus cos theta I can write. And second one, if you taken the component, that will be vertically downwards, it will come as E minus sin theta. So if you observe this, the Q naught is imaginary charge, Q is the charge. In the dipole, both charges are same. Next, the distance of the point from the both the charges. If you see this diagram, in the diagram, from the center, the negative charge is at distance of L. From the center, the point is at distance of X. Then the distance of the negative charge from the point is nothing but, according to Pythagoras theorem, I can use under root of, that is nothing but L square plus X square. The distance of the negative charge from the point. Similarly, the distance of the positive charge from the point is also same, because from the center, the positive charge is at distance of L. From the center, the point is at distance of X. So the hypotenuse gives the distance of the positive charge from the point. So that means this is also, if you apply the Pythagoras theorem here also, that is also under root of L square plus X square. So if you observe this one, minus Q plus Q, magnitude is same, the distance of the point also same. That means the electric field intensity depends on charge, magnitude of the charge and distance of that, right? Square of the distance. So in the both the cases, in this case, both the minus negative charge and positive charge, magnitude is same, distance also same. That means electric field due to both are same. So at this point, I can say electric field due to the positive charge E cos theta, E is cos theta, both are same. And here also in the vertical direction also, electric field due to E sin theta, both are same. But in the case of vertical, both are equal in magnitude. E sin theta, same value, but direction is opposite. Opposite means one is upwards, one is downwards. What is the net electric field? The net electric field, okay, along y direction is equal to 0. There is no electric field. But along x-axis, we have a net electric field. What is the net electric field? That is nothing but 2E cos theta. Now this electric field, which is along x-axis, which we are finding, that is the electric field on that, okay, axial line, equatorial line, we can say. So electric field along equatorial line is equal to that we are getting as 2E cos theta. Now we need to find the derivation for this 2E cos theta. Now what is E here? E is called electric field. Electric field due to any one of the charge. Electric field formula 1 by 4 pi epsilon naught charge Q by square of the distance. What is the distance here? L square plus X square whole root. So in this case, according to formula, square of the, okay, value, that is under root of L square plus X square whole square. So that means what is the electric field at that point? Electric field is equal to, I can write 1 by 4 pi epsilon naught, that is Q by, so L square plus X square. This is the value of electric field at that point in terms of magnitude. Next, what is cos theta from the diagram? So cos theta can be calculated using the triangle. You can see from the center of the dipole to, if you see, there are two right angle triangles are there, which makes an angle 90 degrees. So from the triangle, any one of the triangle, what is cos theta? Adjacent by hypotenuse. Adjacent by hypotenuse value how much? L by, that is remaining is L square plus x square root. This is the cos theta value. Take this cos theta value and whatever the e value, substitute in the equation which is given. Substitute here, what you get, which equation this is. Electric field along equatorial line is equal to 2 times of electric field, that is 1 by 4 pi epsilon naught. I am writing as k, constant k, into, that is q by, that is L square plus x square, I can write, into, okay, L square plus x square, that is e value over. Next, cos theta. What is cos theta? Cos theta is nothing but L by, that is L square plus x square, L square plus x square whole power 1 by 2, I can write. Root means whole power 1 by 2. So bases are same, means power must be added. So what is the electric field along equatorial line? You get E is equal to 2 times of k into q into L by, this I can write as L square plus x square whole power 3 by 2, I can write. Now this we have to write in the form of dipole moment. What is the dipole moment? P. So you know that dipole moment P is equal to, always statement is charge into length of the q into 2l. So I can write this one in the form of like this. If you want to write this one, this is already we have a 2, we have a q, we have a L. Directly we can write. So electric field along equatorial line is equal to, simply I can write as P k by L square plus x square whole power 3 by 2, I can write. Now what is k? 1 by 4 pi epsilon naught. I can write in the order E is equal to, that is 1 by 4 pi epsilon naught into, that is P by L square plus x square whole power 3 by 2, I can write. This is the electric field intensity along equatorial line. Now we are going to understand some more concepts here. If the length of the dipole, that means in this case this length of the dipole is very small compared to which one? Distance of the point. That means if L is less than x, I can put the L value 0. Electric field along the equatorial line is equal to what you are going to get? 1 by 4 pi epsilon naught, that is P by, okay, this is nothing but what you are going to get? L value 0 means x square whole power 3 by 2. That becomes x cube. So the equation of electric field along equatorial line, how much you are going to get? 1 by 4 pi epsilon naught P by x cube we are going to get from the case of short length dipole, that is if the length of the dipole is very small compared to distance of the point. Now here our concept of understanding one more is, this electric field is a vector quantity, right, having particular direction. Dipole is also vector quantity having particular direction. Now what direction this dipole is? Here also electric field is inversely to cube of the distance only. In the axial line also electric field is inversely to cube of the distance only. There we got 2 times, here we have not got any 2 times, 1 by 4 pi naught P by x cube we got. That means electric field and dipole moment, what is the relation between these two? If you observe the diagram, so here I take a negative charge, positive charge of the dipole. What is the direction of the dipole moment? Already you know that. The direction of the dipole moment in the case of, okay, this dipole is equal to nothing but like this. This is the direction of the dipole moment, that is P. Yes or no? Negative to positive. This is the direction of the dipole moment. But if you see the equatorial line, along the equatorial line, what is the direction of this electric field? This is the left to right. That means we are getting, this is the direction of the electric field we got. Equatorial electric field like this. That means what is the direction? The dipole is one direction. The electric field due to this dipole along equatorial line is opposite direction. Means what is the angle between these two? Theta is equal to 180 degrees. So in the case of axial line, the angle between dipole moment and electric field is 0 degrees. In the case of equatorial line, the angle between dipole moment and electric field is 180 degrees. It is always opposite. Suppose if we taken the positive charge this side, negative this side, this resultant electric field you are going to get other side. So this is one of the concepts you need to understand. So what is the electric field along equatorial line? 1 by 4 pi naught P by x cube is the formula for that one. For the short dipole for the any length considered dipole 1 by 4 epsilon naught p by L square plus x square whole power 3 by 2 is the formula. The concept is electric field and dipole both are opposite. Always electric field will be opposite to dipole in the case of equatorial field. In the case of axial field, it is always in the direction of dipole movement. This is the concept of electric field along dipole. And next we are going to discuss electric field due to dipole at any position other than axial, other than equatorial. Now we will discuss about electric field due to dipole at any position. So along any position means you can take the point anywhere on axial line, equatorial line, in between axial equatorial, at any position you can take. Axial line means what is the angle? 0. Equatorial means what is the angle? 90. So at 90, right? At any angle that you can calculate other than 0 and 90, we can calculate now, and you can verify this equation also. So here first I taken one of the dipole which is having positive and negative charges here. So in this case I taken the positive charge. Okay, I taken negative charge here, and I taken the positive charge here. So electric dipole moment always in the direction of, what is the direction of the electric dipole moment? Always in the direction of negative to positive. This is the direction of the dipole moment P. Now I taken one of the equatorial line also, and I can take axial line also. Now I chosen one point in the screen, a point. At this point I want to calculate. So this point is at a angle. It is at a particular angle. So this angle, that means what is the distance of the point from here? This point from here, this point is chosen. This point is chosen. This is the distance of this point, right? At a angle, this point is chosen at an angle of theta. As we're looking here, this point is chosen at an angle of theta here. So now what angular position? If it is 0, if the angle is 0, it becomes axial line. If the angle is 90, it becomes equatorial line. So at this point we need to calculate electric field intensity. That electric field intensity I am writing as E theta. Before EA axial field, EE equatorial field, now it is E theta. So in this case, to explain this one, to understand easily, first what you have to do is, this dipole moment is a vector quantity, right? This is a vector. So this is the direction of the vector, you can see. Now what we are doing is, this vector, whatever it is, okay, the vector which are doing whatever it is. Now if you see this one, this is a vector, right? This vector. Now what we are doing, this vector, now this vector we are resolving to common, because this vector is making an angle theta with this line joining of this one. Now what distance the point is chosen? The distance of the point we chosen is x always. This is x. Now what I am doing is, this dipole moment we are resolving to component. One component you will get in the direction of the line theta side, that is cos component. Another one perpendicular you will get. So I am taking the vector here. So one component is in this direction, the dipole moment component. This is the way the dipole moment, one component will be there. This is the component of P. If P is the dipole moment, then P cos theta is the component of that. Okay, next component, what is the next component? Another component is perpendicular component. So that component will be what direction it is. Okay, one component like this means another component will be like this. This is the way the second component. This is important to understand here. The dipole P, which is there, the dipole moment is a vector quantity. We taken into components, that is, one is P cos theta component, second one is P sin theta component. I can take it like this. So when you taken the dipole moment as a two components, now P cos theta dipole component is in the direction of the line joining of the point P. So that means along the line joining of the point means it is looking like axial point for this P cos theta. That means this point P which we are taking, it is becomes axial line to P cos theta. The same point, the line joining of this point P, the line joining of the point P, for this P sin theta, it becomes perpendicular. Perpendicular means that becomes equatorial line. So apply the concept of calculation of electric field due to this dipole at this point due to P cos theta, P sin theta. So electric field due to that at that point is equal to due to E cos theta and E sin theta. One component is e cos theta, that is I cap, and the second component is e sin theta, that is j cap. So to calculate this electric field at that P point, if you, at P point to calculate, so first electric field at that P point along axial line, I'm taking like this. What is the axial line formula? Already you know that 1 by 4 pi epsilon naught. Axial line formula 2 times of dipole moment. Now, but what is the dipole moment along that axial line now? Now the point P along the direction P cos theta, so you take P cos theta by square of the distance of that. Now, what is the distance of this one? The distance of this one is x, so I can write as x square. I can write it here. X square is the distance of that point. This L is the length of the dipole anyway. Based on this one, we can modify later. So this is one. Next, similarly, if you go to the next, what is the electric field due to dipole moment which is perpendicular? That means P sin theta is the dipole moment, and for that, this point P line, the line joining of the point P will becomes perpendicular. That is called equatorial line. So electric field due to this dipole along equatorial line. Along equatorial line, I can write as E is equal to, formula is already we derived, along equatorial line 1 by 4 pi epsilon naught. What is the electric field due to any dipole along equatorial line? That is P by x square. Yes or no? What is P dipole moment? Only P is there is no 2 is there. So just before we done the derivation, so P. In the case of P, what you have to take, which component is effective? That is P sin theta. So I'm explaining once again. I taken minus q plus q, and we chosen the point which is making an angle theta. Now this is the dipole moment which is making an angle theta. Resolve this dipole moment into component. One is P cos theta, second one P sin theta. Now the point which is there, in that direction of the point, P cos theta is effective. That dipole moment is creating the electric field at that P point. Next, P sin theta. With respect to P sin theta, this point is perpendicular. That means the line joining of the point is perpendicular. So this point becomes equatorial. So electric field due to this P sin theta becomes equatorial field at that point P. That is only I am writing 1 by 4 pi naught P sin theta by square of the distance of that one. That is also x square. Square of the distance anyway. Same. Now, what is the direction of that electric field? Now you know the concept that electric field due to any dipole. Electric field due to dipole along axial line is in the direction of the electric field. So dipole moment is O to P. So electric field also O to P. This is the direction of the axial field due to P cos theta. Now what is the direction of the electric field due to P sin theta? P sin theta is nothing but equatorial line. That line becomes equatorial. Equatorial means what is the direction of the equatorial field? Always opposite. If the P sin theta is downwards, electric field due to that P sin theta is opposite, that is upwards. This is nothing but electric field due to which one? Equatorial. Now both are supported by 90 degrees angle. So in this case, the resultant of these two will be along the diagonal. It will come like this. Now this is nothing but called as E theta. That means electric field due to this dipole at any angular position E theta. So we need to find this now. Clear? So in this case, this one is making certain angle alpha with respect to x-axis. We'll discuss later about regarding that. So in this case, now what is E theta? It is between two. That is EA and EE. So I can write that one. So E theta is equal to nothing but this is under root of, because you have to apply the parallelogram law of vector addition. 90 degrees is the angular separation between these two. So I can write as simply EA square plus EE square. Remaining everything is 0 because cos 90 is 0 based on this. Now substitute the values which you done above. Already I taken here under root of, what is EA? That is k into 2p cos theta. 1 by 4 pi epsilon I taken as k by x square, that is whole square, plus second one is k into p sin theta by x square whole square. Now what is, we can take it common from both here. I can take some things common here. So E theta is equal to K2P, that is Kp x square is common. You can take it outside of that one. So that means if you taken of that, under root of that is under root of Kp by Kp by x square whole square. If you taken common, what I can write remaining I can write as, that is nothing but cos theta whole square, means that is cos square theta, that is 2 is also there, that is nothing but 4 cos square theta, plus next one is sin square theta. I can write sin square theta. Now what is 4 cos square theta sin square theta? Now I can write 4 cos square theta is equal to, I can write as 3 cos square theta plus cos square theta. If you written that one, I can write E theta into, this is under root of, okay, that is Kp by x square whole square into 4 cos square theta, I can write as 3 cos square theta plus cos square theta plus sin square theta. Now what I can write this cos square theta plus sin square theta as 1. If you written that one, and remaining is, if you taken out of the root, this is square and root get cancelled, I can take it outside. Kp by x power, sorry, x square, if you taken Kp by x square, what you are going to get, Kp by x square, if you taken, this becomes under root of 3 cos square theta plus 1. So E theta is equal to Kp by x square into 3 cos square theta 1 is the one of the expression we got in this. See here we taken one, okay, small relative, okay, variation, that is there is a small error is there. What is that? Electric field along axial line formula is 1 by 4% 2p cos theta by x cube, already we derived. Electric equatorial field also by x cube. So everywhere not x square, that is x cube. So if you take an x cube, this one, the answer also we are going to get x cube. So Kp by 1 by, so I can write this one in terms of E theta is equal to nothing but, so 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, that is P by x cube into under root of 3 cos square theta plus 1. I can write. Now here apply the condition. If it is axial field, theta is equal to 0, that is E0 is equal to, okay, what I can write, put the 0 value. Cos 0 is equal to how much? 1. 1 means 3 plus 1, root 4. Root 4 means what is the value you are going to get? That is k, 1 by 4 plus 1. Again, writing as k into 2, you are going to get. Root 4 means 2, that is 2p by x cube. It is similar like axial field formula what we done just before. And what is the electric field along equator line? That means along equator line is equal to, if you want to find, so that means E. What is the angle of the equator line? 90 degrees. If you put the value of that one, k into p by x cube into under root of, okay, this is under root of 3 into cos 90 degrees plus 1. Cos 90 how much? 0. That is totally, this becomes E 90 degrees, that is nothing but electric field along equator line is equal to what you get? Kp by x cube you get. That is nothing but similar like what you did the derivation before. This is the equation you are going to get. Okay, this is the way you are going to get the equation. You can check the previous one. So this expression can be used to find the electric field intensity due to dipole at any angular position, either 0 degrees, 30 degrees, 40 degrees, 90 degrees, any position you can find. So this is the basic dipole concept is over. Next class we will discuss about the competitive concept related to this dipole, how we are applying to different concepts of that, and we have some additional concepts also is there that relate to mains and advanced. We will discuss in the next class.